The Pacific Basin is Earth's largest geological structure, a vast depression formed by tectonic motion over hundreds of millions of years. Despite decades of exploration, much of its seafloor remains mapped in low resolution. In early 2026, a high-resolution oceanographic survey was initiated along a remote sector of the central Pacific Basin. The objective was routine, detailed tectonic mapping using advanced multibeam sonar arrays. These systems emit controlled acoustic pulses toward the seabed, measuring the return signal to construct precise, three-dimensional terrain models. At a depth of approximately 4,200 meters, the returning data began to show irregular consistency. Instead of chaotic volcanic terrain, typical of deep ocean crust, analysts observed linear elevation patterns. The formations appeared aligned, symmetrical, repeated across nearly 2 kilometers. Initial assessments suggested possible data interference. Signal reflection errors are not uncommon in extreme depth conditions. However, 3 independent scan passes produced identical geometric readings. The anomaly was confirmed. Geologists compared the structure against known basaltic formations, including columnar jointing and tectonic uplift patterns. While nature can produce remarkable symmetry, the scale and alignment observed here were statistically uncommon. To investigate further, a deep-sea autonomous submersible was deployed. Engineered to withstand pressures exceeding 400 atmospheres, the vehicle descended into complete darkness. Below 1,000 meters, sunlight no longer penetrates. By 4,000 meters, temperature stabilizes near freezing, and visibility depends entirely on artificial illumination. As the submersible's forward arrays activated, suspended particulate matter reflected through narrow beams of light. Gradually, elevated structures emerged from the sediment plain. Rectangular ridge systems, angular transitions between surfaces, vertical formations casting elongated shadows across the seabed. Surface erosion appeared minimal compared to surrounding terrain, suggesting unusual structural density. Robotic manipulators retrieved multiple rock core samples from distinct sections of the formation. Laboratory analysis later confirmed dense basaltic composition. No metallic alloys, no synthetic compounds, no evidence of manufactured material. Yet internal mineral layering revealed compression gradients inconsistent with adjacent crust samples. Geophysical simulations are now underway to model extreme tectonic stress conditions that might reproduce similar symmetry. Current assessments indicate a rare but plausible natural origin. However, the probability distribution remains incomplete, pending expanded seismic imaging. For now, the structure remains unclassified, a silent formation resting more than 4 kilometers beneath the Pacific surface, a reminder that Earth's oceans remain one of the least understood environments on the planet, and that even in an age of satellites and planetary exploration, our own world still holds unanswered geometry beneath the sea.